Hello everyone, you're welcome to Explore Insights. So today in this video, I want to show you on how to implement edge detection using Canny on your images. So let's quickly dive in. So the first thing I'm going to do is to import libraries. Now I'm going to import CV2, I'm going to import OS, I'm going to import globe. So the next thing I would like to do is to specify the image parts and the destination parts. So I'll assign that to individual variables. From the image parts, I'm giving that as img parts. Okay, so I'll just introduce my raw string. While for the destination parts, I'm going to assign that to a variable dest parts, introduce my raw string. So for the image part, I'm going to locate where the images are I'll be using. So I'm just coming here to get my images. I want to use these images. I'm going to copy and paste. And then for the destination parts, I'm coming over to this folder, which is empty. So I'll just copy and paste. So once I finish processing my images, I want it to be saved in that part. So in my third cell, the first thing I want to do is to initialize a counter I. So to keep track of the number of processed images. So I'm going to say I equals to 1. And the next line of code is to introduce my for loop. So I'm going to say for im in globe.globe. Now I'm going to introduce my image parts here, concatenate it, *.*. So this loop iterates over each file in the directory path specified by img. Okay, so the next thing I'm going to do is to introduce the sub loop, the try and the except. So the essence of the try and except block is used to catch and handle any error that might occur while processing the images. So try sub loop, I'll first of all read the image by assigning that to a variable called image cv2.imread. So I'm going to read the images from here. And next, I'll be converting those images to grayscale. So I'm assigning that to a variable gray, and I will use the cv2.cvt color, remember capital C function, and I'll be introducing the image and the cv2.color underscore bgr to gray. So this will help to convert our RGB images to grayscale images. So since we are working on the edge detection using Canny, the first thing I would like to do is to apply bilateral filtering to the grayscale images. So this will help to reduce noise in the image while preserving the edges. So that's what I want to do first. So I'm going to assign that to a variable noise free cv2.bilateral filter. So take note of the capital F. So I'll go by gray 1117 by 17. So let me talk about this value. So the first one we have here is the diameter of each pixel neighborhood. And next we have the sigma color. So the greater the value, the color far to each other will start to get mixed. And lastly, we have the sigma space. So the greater its value, the more further pixel will mix together, given that the colors lie within the sigma color range. So at this point, we want to apply our edge detection. So we will be doing that by assigning a variable edge img. So that will be, we'll be using the cv2.canny function. So at this point, we have the noise free. We're using this image we've processed by reducing the noise. And then we are going to set two threshold values, which will be used to determine the edges in the image. I'm going to use 170 and 200. The next is to change the current working directory to the directory specified by this part. Okay, so I'll use os dot change like change directly, CHDIR, and our destination part, which is dest part. And the next thing is to create a file name for the processed image based on counter I. So I'm going to set that as file name. So let's say new images. So I will concatenate that string I. And also with the image formats we would like to put, so PNG. So further step is to write the edge detected images to disk. So we'll be using the imWrite function from OpenCV. So we have cv2.imWrite, which will go with the file name and the edge image. And lastly, we are going to increment the counter by 1 to keep track of the number of the processed images. And then for the except sub loop, we want to print a message if there's an error while processing an image. So I'll go ahead to say print operation not executed. So these are just the line of code for our Canny Edge detection. So let's see what we've got by running each cells. Okay, so this is nice. So we'll be able to achieve the edges of each images. So let me open it so that you can take a look at that. So this is what we're able to get from an image both. And let's see for the bus. So we have this. And then for the car, we have this. Okay, so I'll be able to show you that. So have a nice time and join me in my subsequent videos. Bye. I'm signing off now.